So we'll have a look at another few trig problems, actually solving the equations when they're a bit more difficult rather than just doing sine to the -1 to get our angle. There are quite a few of these problems, so I'm just going to go through as many as I can, and then there'll be a second video as well that you can have a look at, and we'll carry on from wherever we stop at. So if we have a look at special triangles at first, so you have to use these sometimes. This is where you've got something like this. So you can see that using Pythagoras' theorem, you do 1 squared plus root 3 squared equals 4, square root of that is 2, which means using these angles, you can see using the definition of sine equals opposite over hypotenuse. Sine of 30 is 1 over 2, but if you do it from this angle, the opposite is root 3, so sine of 60 is root 3 over 2. That's the general rule for special triangles, and you can use it for cos, you can use it for tan as well. So if you have these ones, then if you know the angle here, then you know that sine of this angle is 4 over 5. And you can use, instead of actually putting into your equation here what sine of this angle is, because it could be something more complicated, you can put in sine of alpha equals 4 over 5 and just use the 4 over 5 instead of the sine of alpha. And likewise for this bigger triangle, and they're the two main ones that you need to know, but just writing out them triangles can be useful if it's told you sine of alpha equals 4 over 5, say. Now if we've got trigonometry again, so things like sines and cosines, and sometimes we might need to change limits. So here we've got y equals cos x, and here we've got y equals cos 2x, like so. So if it's told us that x is between minus 180 and 180, then for our 2x version, then that's going to reach these values instead. It's going to reach the same sort of values that x would, but between 360 and minus 360 instead. So if we do a quick example of what I mean by that, so if we're solving cos 2x equals 0.81, we're working, so where cos 2x equals 0.81, so about here somewhere. So if we're solving that between minus 180 and 180, and then we just sketch on our graph what it looks like. You might think, oh, it says between minus 180 and 180, why are we going all the way up to 320? Well, that's because it's 2x, so we need to expand our limits to between minus 360 and 360. And we just sub in cos to the minus 1 of 0.81 and get what our values of 2x are. And that gives all of these. And then we divide everything by 2, and that's obviously going to be these things. So 324.1 divided by 2 is going to be between 180 and minus 180. So if you've got 2x, then you want to double your limits to search between, and you'll find that you'll have x values come out that are between the minus 180 and the 180 you're looking for. If that makes completely no sense, then message me or ask a question in the comments, and I'll try and get back to you to make it a little bit more clearer. And watch the next video, and you'll be able to see some more complicated ones. So when you've got things like squareds in there, or if you've got something like x plus 40 degrees instead of just x in the cosine.